Okay, this video will contain several examples of finding the equation of a tangent line to whatever the function is at a certain point. Remember, to find the equation of the tangent line, we need the slope. And to get the slope, we have to take the derivative, right? The derivative at the x value they give us will be the slope at that point. So let's start with this one. 2x sine x. We basically have a product rule that we have to work with. So remember, product rule is f prime g plus f g prime. So first, the derivative of 2x, which is 2, times g plus f times the derivative of g. So the derivative of sine x is cosine x. All right. We are going to say, what is this f prime of x at pi over 2? So that's 2 sine pi over 2 plus 2 times pi over 2 cosine of pi over 2. Well, it turns out, if we look at the cosine graph, this is 0, pi, 2 pi, and you could put it in your calculator and see it as well. Pi over 2 of cosine is 0. So this is 0. So this whole term is 0. So f of pi over 2 equals 2 times the sine. Now the sine looks like this. So at pi over 2, the sine is 1. 2. So that means the slope at this point, pi over 2 pi, whoops, that should be equals 2. All right, remember, when we're finding the equation of the tangent line, we start with y equals mx plus b. We know an x and a y, and we know the m, so we will solve for b. So y, pi, equals 2 times x, which is pi over 2, plus b. Well, that's just pi. So pi equals pi plus b. Subtract pi from both sides. b equals 0. So our final equation would be y equals 2x. That's the equation of the tangent line at this point. Okay? Let's do the same thing here. Again, we need the slope. You use the first derivative, right, to find the slope. All right. Now, this I'm going to rewrite as x to the 1/4 because it'll be easier to take the derivative of that. So y prime equals 1/4 x. If I subtract 1/4 minus 1, I get negative 3 over 4, don't I? And that looks like this, 1 over 4, and it would be the 4th root of x to the 3rd. Now, they made it decently easy for us because our x is 1, isn't it? So if I plug 1 into this, I get 1 over 4, the 4th root of 1 to the 3rd. So that's just 1. So our slope at that point is 1/4. So our slope is 1/4, and the point is 1, 1. Go y equals mx plus b. Y is 1, the slope is 1/4, x is 1 plus b. Subtract 1/4 from both sides. b equals 3 over 4. Right? So now we got a b and we have our slope. So y equals 1/4 x plus 3 over 4. All right? See, we're doing the same thing over and over. We're finding the derivative, and we're finding the slope at that x using the derivative, and then we're using the point and the slope to find the equation of the line. Okay, here's the next one. Here we will find the equation of the tangent line and the normal line. So I need the slope for the tangent, and then we will figure out the slope that's perpendicular to that. So let's do y prime. Well, the first one's the power rule, right? So this is 4x to the 3rd. Remember, the derivative of e to the x is simply e to the x, isn't it? So this stays e to the 2x. Let's evaluate this at x equals 0. So that's 4, 0 to the third, plus 2e to the 0. This term is 0. E to the 0, remember, equals 1. So y prime at x equals 0 is 2. That means that's my slope, right? So now I have that slope of 2 and the point of 0, 2. So y is 2 equals mx plus b. That's 0. b equals 2. Overall, y equals 2x plus 2. Now, should have left myself more room. If the slope of the tangent line equals 2, the slope of the normal line, which is perpendicular to the tangent, remember, slopes related perpendicularly are the negative reciprocals. All right? So the slope of that normal line then is negative 1 over 2. So let's come over here to the normal line. Slope normal is negative 1 over 2. It's at the same point, 0, 2. So y equals mx plus b. Guess what? B still equals 2. So our normal line is y equals negative 1/2 x plus 2. All right, so perpendicular slopes are negative reciprocals of each other. All right, we're using some of our trig functions now, as well as the chain rule to find these derivatives. So if y equals sine of sine of x, then y prime first is the derivative of sine of x is cosine of sine of x times the derivative of the inside. The derivative of sine is cosine. So this is what my derivative looks like. Okay? I'm going to evaluate that at pi, where x equals pi, right? So y prime cosine of sine of pi times cosine of pi. Well, you could look in your calculator to find this, but I know that sine of pi is 0. So this becomes cosine of 0 times cosine of pi. Well, let's draw our cosine. Here's 0, here's pi, here's 2 pi. Cosine of 0 is 1. Cosine of pi is negative 1. So the slope, y prime, equals negative 1. That's the slope of this line at this point. So to find the equation, we get y equals mx plus b. Y of 0 equals the slope, negative 1 times pi plus b, which is negative pi. So I'm going to add pi to both sides. B equals pi. Final equation. Y equals negative 1x plus pi. That's the equation of the tangent line at that point. Okay? Next. Again, we keep finding the derivative, and we evaluate it at the x point to get the slope. First derivative tells us the slope. So, this derivative, we'll use the chain rule. First, we have to do the power rule. Right? So if this was x to the 10th, the derivative would be 10x to the 9th, right? Oops, sorry about that. So this becomes 10, 1 plus 2x, that stays on the inside, to the 9th, then times the derivative of that inside piece, which just happens to be 2. So this is 20 times 1 plus 2x to the 9th. Well, at x equals 0, this becomes 20. 1 plus 2 times 0 to the 9th, 1 to the 9th. So the slope is 20, isn't it? Using a slope of 20 and a point of 0, 1, y equals mx plus b. That's just 0. b equals 1. Y equals the slope x plus b. There's the equation. All right, I'm going to back up for a second. Yeah, that looks right there. Okay. Alright, this is getting close to the last one, I think. Maybe not. I could be all correct up. Now I like to write this so I can use the power rule. So I'm writing it 1 plus x to the third raised to the 1/2, right? Because the square root, if you write it as a rational exponent, is raised to the 1/2. Right, so the prime, first I do the power rule, 1/2, 1 plus x to the third to the negative 1/2, right? I subtracted 1 from that. Now I have to multiply by the derivative of the inside. Well, that's 0, so it'll be times 3x squared. Okay, let's rewrite this for a second. So I got 1/2, and I have 3 on the top, 3x squared, but on the bottom, I have this 1 plus x to the third. I will evaluate this at x equals 2. 3 times 2 squared over 2 times 1 plus 2 to the third. 2 to the third is 8, plus 1 is 9. Square root of 9 on the bottom is 3, times 2 is 6 in my denominator. 2 times 2 is 4, times 3 is 12, right? So my slope actually equals 2. So using this point and this slope, let's find the equation of the line. Y is 3 equals the slope times x plus b. That's 4, so let's subtract 4 from both sides. B equals -1. So using this and this, y equals 2x minus 1. Okay? All right. Now here's another one where we're using our trig functions. The one thing I want to make sure you understand is that if you have something that says sine squared of x, that is the same thing as sine x squared. So sometimes it's easier to write it that way in order to take the derivative. So I'm rewriting it like this. Okay, y prime. Right, the derivative of sine is cosine x plus, first I treat this with the power rule, 2 sine x to the first, right? I don't need to write that, but the derivative of sine is cosine. So this is what we have, cosine x plus 2 sine x cosine x at the point 0, 0. Cosine of 0 plus 2 sine of 0 oops, that's a 0, not a theta. It's hard to write. 0. Now, I do know that according to sine of 0 is 0. So this term will be 0. Cosine of 0 is 1. So y prime equals 1 at this point, doesn't it? So now, y equals mx plus b. B equals 0. Therefore, we got a slope and we got a b. Y equals 1x. That's that equation. Let's see. All right, so there are several examples of finding the equation of the tangent line for any function at a certain point. So the process is, right, take derivative. We need the first derivative, right? Evaluate at the given x. That is the slope, isn't it, of the tangent line at that point. And then 3, using slope and point given, find equation of line. All right, so take a look at these and practice them. And I think you'll find the more you do, you can see the process is really the same thing over and over again, ad nauseum. So just do the practice and then we'll talk. Thanks.